Hi students, in this session we are going to discuss about a new chapter from chemistry, chapter 3, metals and non-metals. I think you have learned about metals and non-metals in your previous classes. About 118 elements have been discovered so far. Among them, about 90 are metals, 20 are non-metals and the remaining they are metalloids. Do you know what are metalloids? Metalloids show the properties of both metals and non-metals, and you will learn about metalloids in your 5th chapter in chemistry. In this class, we are going to discuss about metals and non-metals. Can you give me some examples of metals? Yes, you are right. Sodium, potassium, aluminium, gold, iron, silver, all these are metals. What about non-metals? Nitrogen, oxygen, fluorine, chlorine, all these are non-metals. Yes, you said it right. Now let us see what are the difference between metals and non-metals in their physical properties. Let us discuss one by one. First of all, metals are solid in normal temperature. That means usually metals are solids, but there is one exception. Can you tell me what is that? That is mercury. You know that mercury is a metal, but it is a liquid. So mercury is a liquid metal. I told you generally metals are solids, but mercury is a liquid, but it is also considered as a metal. Now what about non-metals? Non-metals can be solid. For example, carbon, sulfur, etc. They are solid. They can be liquid. Bromine, it's a non-metal, but it is liquid in state. Then they can be gases. For example, chlorine, you see oxygen, nitrogen, all these are non-metals, but they form in gaseous state. So the first difference is metals are solid in nature, but there is one exception I told you. While non-metals they can exist in solid, liquid and gaseous state. Now let us see the next difference. The next one is metals are usually hard. What do you mean by hard? Hard means you cannot cut with a knife very easily. Iron, aluminium, copper, all these are metals and they are very hard. But there is some exceptions. Just like sodium and potassium. They are metals, but they are not hard, they are soft. They can be cut even with a knife. So generally metals are hard, but there are some exceptions. I told you sodium and potassium. They are metals, but they are soft. Now what about non-metals? Non-metals are generally soft. Non-metals are soft, but there is one exception, that is diamond. Do you know what is diamond? Diamond is an allotropic form of carbon. Carbon can exist in two forms, and these two forms are called allotropes. The first allotrope of carbon is diamond and the second allotrope is graphite. Carbon is a non-metal. Now diamond, though it is a non-metal, it is very hard. It is the hardest substance that exists in nature. You see, usually non-metals are soft, but there is one exception, that is diamond, the allotropic form of carbon. Diamond is the hardest material that exists in nature. Now let us see the third one. Usually metals have high melting point and boiling point. Why? They are solids, that's why. So the intermolecular attraction, that is very strong. So usually metals have high melting point and boiling point. But there is some exception. Cesium and gallium, you see, they have very low melting point and boiling point. You see, if you take a piece of gallium or cesium, and if you keep in your palm or if you keep outside, it gets melt. That means though the metals show high melting point and boiling point, gallium and cesium, they have low melting point. Now non-metals. Non-metals have very low melting point, But there is one exception, the allotrope diamond. Diamond has very high melting point and boiling point. Generally, metals have high melting point and boiling point, but there are some exceptions I told you, gallium and cesium. Non-metals have low melting point, but there is one exception, that is diamond. Diamond has maximum high melting point and boiling point. Now the next difference is malleability. What do you mean by malleability? Malleable. Malleable means the metals can be beaten into thin sheets. You see, we use iron sheets, aluminum sheets in our day-to-day life. That is because of the property called malleability. Malleable means metals can be beaten into thin sheets. Gold and silver, they are the most malleable metals. Now, what about non-metals? They are not malleable. Now, the next difference is about ductility. What do you mean by ductile? Ductile means metals can be drawn into thin wires. From metals, we can make wires. That is known as ductility. Gold and silver are the most ductile metals. If you have 1 gram of gold, from that 1 gram of gold, you can make a wire of length 2 km. You see, the gold and silver, they are the most ductile metals. Now, what about non-metals? They are not ductile. Because of malleability and ductility, because of these two properties, metals find applications in our day-to-day life, because metals can be converted into desired shapes, okay, into many shapes. The next difference is metals are lustrous. What do you mean by lustrous? In pure state, metals have a shiny surface, that is known as lustrous. So, metals are lustrous. That means they have shiny surface. Now, what about non-metals? Non-metals are not lustrous, but there is one exception, that is iodine. Iodine is a non-metal, but that is lustrous. Now, the next difference is metals are sonorous. What do you mean by sonorous? Sonorous means if you just hit a metal hard, you can hear the sound. The metals produce sounds when they are beaten. That's why metals are sonorous. What about non-metals? Non-metals are not sonorous. Now, the next difference is metals are good conductors of heat. Metals can conduct heat through them. That's why metals are good conductors of heat. But there is one exception, that is lead. Lead is a metal, but that is a poor conductor of heat. Now, what about non-metals? Non-metals do not conduct heat. You know, they are bad conductors of heat. Now, the next difference is metals are good conductors of electricity. You see, we use, aluminum, copper wires, etc. for transmission of electricity. Why? Because metals are good conductors of electricity. Now, what about non-metals? Non-metals are bad conductors of electricity. But there is one exception, graphite, the allotropic form of carbon. I told you carbon exists in two forms. One is graphite, the other is diamond. I told you that. They are known as allotropic forms of carbon. So here, graphite, an allotropic form of carbon, which is a non-metal, but it is a good conductor of electricity. Metals lose electrons and they form positive ions. For example, sodium, magnesium, etc. When they take part in a chemical reaction, they lose the electron and become positive ions, or they become cations. Now, what about non-metals? Non-metals accept electrons and become negative ions, or we say that they become anions. For example, chlorine, oxygen, etc. So, these are the differences between metals and non-metals based on their physical properties. This topic is very important. In this discussion, you see, we come across some exceptions. You see, metals are solids, but there is one exception, that is mercury. All metals are solids, but mercury is a liquid. So, these exceptions are very important and you should know these exceptions, because for your examination, one question will be there surely from this topic.